Watch this very closely. I start with a purple liquid, but as I pour it into these jars, something strange will happen. Are you watching? Welcome to On the Shoulders of Science. I'm Ben. If you question the why about things in this universe and you want to learn about random and interesting scientific facts and concepts, then consider subscribing and clicking the bell to be notified when a new video comes out. Okay, so what just happened there? Why did the liquid in those jars just spontaneously change color? Well, if you have a guess, go ahead and put it in the comments. Okay, are you ready to find out what just happened there? Well, it all starts with a cabbage. Cabbage juice. Yummy. You see, cabbage juice has pigments in it called anthocyanins, and anthocyanins are water-soluble pigments found in a variety of fruits and vegetables. They're found in blueberries, cherries, grapes, and interestingly, the highest concentration of anthocyanins are found in purple corn leaves, about 100 times that of red cabbage. But anyways, anthocyanins are special because they change color depending on their pH. pH. You hear that word thrown around a lot, but what does it mean? pH isn't just some fancy number you see on water and shampoo bottles. It actually has to do with the amount of hydrogen ions dissolved in a solution. Take this lemon, for example. It's mostly water, but it has some citric acid dissolved in it. And some of that citric acid dissociates or breaks apart, freeing up those hydrogen ions, essentially atoms of hydrogen with a missing electron. And that's what pH is, the concentration or the power of hydrogen in a solution. And keep in mind the pH scale is inverted, so a low number means there's a high amount of hydrogen ions and therefore a high acidity. And the pH scale is also logarithmic, so something with a pH of 2 has 10 times the amount of hydrogen ions as something with a pH of 3, which is 10 times higher than something with a pH of 4, which is 10 times higher than something with a pH of 5, and so on. So what I did here is at the beginning, I put a tiny amount of different substances with different pHs so that the pH would be different at the end. In this jar, I put concentrated hydrochloric acid. In this jar was vinegar. This jar I didn't put anything. This jar I put baking soda, and this jar had bleach. But how does this work? Why the color change? Well, pH indicator molecules are weak acids themselves. If you want to learn more about weak acids and pH, you can click this video here. But essentially, each molecule of a pH indicator has a hydrogen ion that only gets released from a fraction of the molecules. And if the pH indicator is in something super acidic, where there's a bunch of hydrogen ions swimming around, the hydrogens tend to get reabsorbed and attach themselves to the indicator molecules. And if it's in something super basic, where there's very few hydrogen ions, the hydrogen ions tend to be released from the indicators, filling that hydrogen ion void. But here's the kicker. The way light reacts with the hydrogen attached and hydrogen removed versions of the pH indicator is different. So each one ends up being a different color. And red cabbage naturally has a bunch of different types of anthocyanins that release and absorb hydrogens at different levels, change colors at different pHs, and change between different colors. So altogether you get this smooth transition between different colors as you move up in pH. Thank you for watching this video. Subscribe to On the Shoulders of Science if you want to see more. And if you like cool chemistry like this, you might also like my video I made on 5 awesome chemical reactions. Link in the description. I hope you liked this video, and I hope you learned something. I'll see you next time.